Hello everybody, my name is Martin Schweighofer and I'm recording this video today because I went to a really cool event called the 4th KTH Workshop on the software supply chain. It happened in 2025, last Friday basically. Today is Monday, and I actually won this nice hat at that event and this Easter egg full of candy. And what I want to do in this video is first of all explain to you why I won that, and second of all, like, it's the competition that I won that in is about like supply chain security practices, and I thought this would be an interesting starting point to look into the measures that I'm taking myself in the development of laut, which is what this prize was about, but also what laut wants to provide to its users eventually. Hello, this is me editing that video now. I'm also providing timestamps for, I think, the two key takeaways, which is, first of all, why does it make sense to build supply chain security tooling on top of Nix? What do you get out of that? And second of all, what is the laut project trying to do? Where are we trying to go with that project? Thanks, enjoy the video. Let's just look at the list, right? So everybody at the event could fill out this sheet of paper for one of their projects and check which kind of measures supply chain security measures they take in their project or not. And so I filled this out, and I ended up winning. Nobody else filled it out actually. So, well, I took the opportunity to get some free publicity for my project and was happy about that. And yeah, so this is the lens that we're going to view that we're going to look at that project through, right? Yeah, this was an amazing event. I had a lot of fun. I'm really happy that I went. There were practitioners there. There were researchers there. There were also some very talented other PhD students and master students working on supply chain security stuff. The Chains research project really seems to be doing a lot of stuff here and open sourcing it, as you can see. They were hosting this in Sweden, so thanks a lot to them. Let's get started, right? So I did this assessment for the laut project, which right now it's not published yet in the scientific sense, but it's something that's work in progress research that I'm trying to get published in the future. And then there is a paper out about the principles that enable it to work and explain how it works. And I'm not gonna be able to cover how laut actually works in this video, because it's not possible in such a short video. So if you're curious about that, I'd recommend that you check out the paper instead. But now let's get to the checklist finally, right? So if we look at the checklist, what kind of stuff is in there, right? There's forbid unsigned Git commits and tags, and it says this is impossible on GitHub. I have my project hosted on GitHub, as I think you saw. Can't really do that, so there's an X here. Forbid transient dependencies in CI, so you're not supposed to just take the latest thing or some snapshot release that isn't going to stick around. And like Nix kind of prevents that by design. I'm gonna show what I mean by that. Let's also look at the second point where I wrote a similar thing. You're also not supposed to just have like a coarse-grained version reference where you reference version 45, but it could actually be 45.0.1 that you depend on. So you want to have one specific immutable version, and Nix also like does that by design. So let's just take a brief look at how Nix provides this to us. So I am in the repository of the laut project right now, and this project is structured as a Nix flake. So for anything that's in there, I can basically show the build instructions for the last build step that puts this thing together actually. And then there's a bunch of other things that build step depends on, and all of these dependencies have a hash in them. And this hash is what enables Nix to have these really precise dependency trees where it knows exactly what's in a specific output, all of the things that eventually led to a specific output. And so it's basically an aggregate of having such a detailed description for every build step. And we can show that with some other command, which is called nix tree. I'm not gonna go into the details, but of how that works and where you get it from, but just show it off. I think I have to get rid of some work in progress changes. Now it works. So here I have basically all of the runtime dependencies and transitive runtime dependencies of my project listed. And since these hashes really require very precise versions, because it has to be some specific at the edges of the dependency tree, at the outside of the dependency tree, it's really some defined thing that's defined by the hashes of some content. And that's why you have this really high quality dependency tree. And I can actually search this for things like OpenSSL, for example. And now I find actually different copies of OpenSSL that I depend on at runtime. And those are not actually different copies of OpenSSL. Those are different outputs that fall out of building OpenSSL. So the library and the executable commands that it comes with, and the header files, and also the Python bindings, which is a different package. I can inspect where they're coming from. I can, for example, for this specific one, I can see, oh, there's 3 ways how I depend on this specific version of OpenSSL and things like that. And this was basically making this statement about the what my project depends on at runtime. If I just add a flag here, I can make equivalent statements about what it depends on at build time, which is even more difficult to do probably with traditional tooling, right? So we have a much larger graph now, and we have really detailed things in here. Like if we look at some random package, like what I'm trying to find is something that's somehow patched, for example, right? Here we have a bunch of patches for Perl, for example. So really down to, okay, this specific state of this specific repository with this patch applied and that patch applied is the kind of statements we can make. And this is something we get out of Nix out of the box, right? So I think Nix is a really interesting basis for building supply chain security tools. But now let's get to the rest of the list. I also have a dependency update bot configured. We can see it created a pull request here. Works with GitHub Actions. That's good. Push log file in repo. Like you can also use Nix in a way where you don't get these nice properties because you don't actually use a log file. But by using flakes, I get this flake.nix file and the corresponding. Well, I'm in the wrong place here. Where's laut? Here. There's this flake.nix file and a flake.log file, and the log file contains a hash for the state of each repository that's involved in the build process here, on the Nix level at least. And that means that some of the hashes of individual projects are actually going to be checked into the Nix packages repository that I depend on, right? So I don't have the hash of everything in my log file to create a huge log file, but sometimes I depend on a specific state of Nix packages, and it has specific hash for each version of it, each package it contains. And it contains about 100,000 packages, so those are a lot of packages. All right, let's proceed. So we have a log file in the repository. We have the dependency update bot. I'm not blocking bad dependencies in CI. Like the Dirty Waters project is trying to do that. This was one of the projects presented at the workshop. Maven log file was as well. You can do that kind of work freestanding. I'd also be curious to see if you do something like this in the Nix ecosystem, you already have this detailed tree and you just have to do like the later steps. There's at least no ambiguity over the tree at that point, right? Require code review before merging PRs. I don't have that yet because I can just merge PRs and I can just push to main. But at this point, I am the main person working on this project, and so it wouldn't be feasible to have everything that I do reviewed by other people. There are some people who have contributed, also some other people who are not listed here who have posted things on the issue tracker. Thank you very much. Yeah, I'm just not there yet. Runs security scanners in CLI, not doing that. No, and also don't have anything interesting to say about it. Release tags also, like, we're not there yet. This is not ready for users. It's still being developed. Automated creation of SBOMs for releases. Well, the way I explained Nix to you, one way to frame that is Nix does source level distribution, and distributing binaries is then an optimization on top of that. So if I consume artifacts from a cache, these signatures that make that secure relate this input hash with a hash of the output. And basically this is kind of a build step level SBOM, where for each individual step in the dependency tree, I have a sign statement about, well, this was produced from this set of inputs. But I don't have like an SBOM per se. But there is a project which enables the creation of SBOMs out of this data that Nix conveniently provides. There are actually multiple projects. Yeah. You can use this dependency tree to generate a traditional SBOM in CycloneDX format, and like integration of that is a thing that I want to do with laut as well. So that people who use these established formats can actually take advantage of laut as well and feed laut's output into other tools. Yeah, push build attestations for releases. Not doing that yet. Have independent rebuilders. Not doing that, but both of those points are kind of related to what I'm trying to do with laut. And so I'm going to take this opportunity to show you what I mean by that. And we're going to look at a specific file for that. Oh, I actually want to apply those changes that I just threw away earlier to do that, so I don't show you a bunch of irrelevant stuff. So laut is actually trying to replace the signature format in Nix, and the signature format in Nix relates, as I said, some hash of the set of inputs to some hash of the outputs. And the two innovative things that it does are related to, well, how do you construct this hash of inputs? And also, let's add a third dimension here. Let's add metadata about the build host. And that's the point of the project. If you want to know more details, I would again refer you to the paper. But really, in terms of what the vision is, in this builder section, it should be able to, it should be possible to specify like a source reference that represents the software state of the builder, and a remote attestation which makes it possible to verify that this software state matches something that corresponds to a remote attestation that's part of this signature as well. So there's going to be a source reference in here and a remote attestation, and you're supposed to be able to close the loop with verification in that way. And like this relates, I think, very much to something we heard at the workshop by Hervé, which he was talking about. Like basically his concluding statement had something like, well, we really would want to have remote attestations of rebuilds, and laut really by design is trying to create something like this, meaning that because you have this data in the builder section, you have your attestation, right? And the role of remote attestation and measures like that, hardware measures, is to give you additional information about how some specific output was produced from a set of inputs. And then reproducibility is something that you reason about on top of these statements that are constructed in the way that laut does it, for example. So either by using laut directly or by using a format that works similarly of, hey, I have a hash of inputs, a hash of outputs, and some builder information that includes a remote attestation. And like the point of laut is, let's make this information, make it possible to aggregate this information and make sure that it doesn't depend on like transitively trusting some other entity that we're not covering with how we do dependency resolution. Yeah, so that's that. Let's move through the list, get the remaining items. I said the main things that I wanted to say, but branch protection rules, no, haven't looked into that yet. Verify dependency crypto signatures from a trusted source. Well, as I mentioned, Nix is source-based, and if I take something from the central cache that is filled by the state of the Nix packages repository, then there is a signature that associates inputs and outputs, but like laut is trying to fill all the gaps in that and add information about the build host. And two-factor authentication enabled for all project members. I myself have two-factor authentication enabled for my GitHub account, but I think you can only set this policy on an organization level. Right now, this project just lives under my personal account, and I don't think you can do that there. And that's it. I end up with a score of 5 because I'm doing 5 things. And nobody else submitted, so I win the competition. I hope that this video provides insightful information to you. If you are curious about these things, how laut works in detail, or want to collaborate on something, let's talk. I'm really very much trying to get people involved in this, independently of whether or not they have a background with Nix. And even outside of Nix, I think like the patterns that I'm using in here are like really interesting patterns, and something that we should look towards when it comes to figuring out where we're going to go with supply chain security. Oh no, there's this core thing that I wanted to show to you, and I kind of just forgot. So we do have, as one of the bullet points in here, have independent rebuilders, and I said that laut is trying to do that, but I do have some actual tests that show that off, and I just wanted to show that quickly. Like what doesn't work there yet is like aggregating information from different builders. This is really the key part. If you don't have aggregation across signatures on the build step level yet, you really don't have anything that interesting. And then at the point where you get a remote attestation in there, it gets really interesting because you can make the software state of the builder part of those huge dependency graphs that you reason about as well. But I can actually start a bunch of QEMU-based VMs. We're gonna first start a cache. We're also going to start 2 different build hosts. And then there's a fourth VM which does verification according to some criteria. So takes things out of the cache and verifies that those things satisfy its own personal trust model of who it does or does not trust. And that's how laut works. That's what it tries to enable. I thought showing the live thing would give some additional value. All right, see you. Bye.